Dear student, we are going to discuss about chapter 9. In this chapter, we are going to discuss about network functions virtualization. So this is the topic. So far we have seen so many concepts related to SDN and their functions, and then security, and there are various component we learn. But in this chapter we start with the network function virtualization that gives you the wider spectrum of idea how these SDN functions as well as that virtualization happens with the devices. Okay, and also I want to tell you that you have to assume that that what we study in the virtual box tool we use for virtual machine configuration and other things. The same way, here also we will use those switches, routers inside the virtual environment, so that everything becomes software. Okay, everything becomes software. Let's see one by one what's going on. Okay, we will complete this chapter in a short span of time, and we will not be extending, okay, with much concept, because this is just introductory things. We are going to see how the functions of all those devices, okay, and how we are going to implement in virtual environment, okay, and their functionalities. So as far as the objectives concerned, that we are going to see how the NBF network function virtualization is going to work, and what exactly the network function virtualization, and we are going to see the overview of the architectural framework of this NBF, NFV, network function virtualization, and then the NFVI, okay, network function virtualization infrastructure. Those the places where the area involves in network function virtualization, and their key benefits, okay, and then there is a differentiation between NVF and SDN. So when you see the background, okay, it's really if you look into that separate network device platform. So each device is it's a hardware based devices. Okay, this is a hardware based devices. And if you look into the virtualization form, okay, virtualized platform, you have everything inside. Okay, so this is like totally software based. Okay, so let's see that the VM technology used. Okay, the background of what exactly we are going to see, this NFV, okay, network function virtualization. So VM technology used for application level server functions such as database server, okay, cloud server, and then web server, email server, and so on. Okay, so this is something we can just use for okay, the virtual machines we can use for all those database server, cloud server, okay, all these I mean options. We can extend our network through virtual machines, but at the same time these technology are used in the switch and the router components and switches, and their functions are emulated into a software form. Okay, so that's what they are clearly say that the same technology, okay, the same technology can equally be applied to the network devices. So far we see only database server, cloud server, web server, and email server, and so on, so many other services. But also we can use for these devices: switches, routers, firewalls, IDS, and IPS. Okay, intrusion detection system, intrusion prevention system. So let's see one by one. Okay, and this is what it is here, that we can see that operating system 1, operating system, this is a virtual machine environment, and there are a lot of machines running inside, and the switch, logical switch, router switch, firewall logic, everything is logic in the sense it is software. Okay, it is software. Okay, so network virtual functions, network function virtualization is a virtualization of network functions. Okay, virtualization of network functions. Okay, by implementing. So if you look at the look into the network overall, network function, so the network is consists of switches and routers and other servers. Okay, working in a fashion that client server and multiple other protocols runs into router, and they forward all those traffics. Okay, so all those traffic, and also there are controls using firewalls. So these are the devices. So in this chapter we are going to see all these devices being converted into the software based devices. Okay, that's the main idea. Okay, software. Okay, the main idea is software. We are going to convert into software. Yeah, so the network function virtualization. Okay, network functions by implementing these functions in software. Okay, and then running them on virtual machine. So just to assume that you are going to use them in the virtual environment. That's it. Okay, so network function virtualization decouples. Okay, decouples. So you have to find out this word couples. Okay, sorry, couples, decouples. Okay, couples means it is joining together. Decoupling means it is just removing them. Okay, it means that uh, removing the software from the hardware. Okay, so it means that the router, software based routers. Okay, software based routers. So if you look into that case, like software based routers, okay, software based switches. So that's the main idea here. Okay, network functions from proprietary hardware platforms, okay, and implements these function in software. So proprietary hardware platform, it's like Cisco, okay, Juniper, okay, Juniper. So there are like lot of other routers like 3Com. So these are the proprietary hardware platform. Their functions are like routing, switching, firewalling, okay, and IDS, IPS, DNS, NAT, everything they do. So that is what we are going to convert them into functions. Okay. So as a summary of this network function virtualization, so still we are going to see a lot of things. So what we see here, the hardware is going to be converted into software. Okay, so that software runs inside the virtual environment. Okay, like VirtualBox, VMware, Hypervisor, so many other virtual platform it can be running. So we have to understand that how the operating systems are installed in the virtual box or VMware. The same way we are going to install routers and switches in a software form. Okay, that's the main idea here. Okay, and also these things run on high performance. Okay, to virtualize network functions, right? So, and also we have the virtual machine technology can be applied to network based devices, including the following. So what are they? We have network function devices such as switches, okay, switches, routers, and then access point, okay, and then customer premises equipment, okay, and then deep pocket inspectors. Okay, it's like Wireshark, okay, and other different kind of pocket inspections tool can be used. Okay, DCP thumb and so many other tools are there. And we have access point and the customer premises equipments, or something we can say that like ATM machine, okay, ATM machine. And we need a router or the switches to be connected to the modem, and then get into the ISP. So these are the things, or can be these are the things can be we can convert them into network based devices. Okay, so it's purely software based. And also network related computer devices like firewalls, IDS, okay, and network management system. Okay, network management, these are the devices also. Okay, convert them into software. And network attached storage like file, database servers. Okay, so these are the various things can be, okay, used as a, okay, these devices can be convert them into, previously we used as a hardware, but according to network function virtualization we can convert them into software based, and that can run on the virtual environment. Okay, so we are seeing now that there are traditional network, all devices are deployed proprietary and closed platform. Closed platform means that you need to have 100% proprietary. Okay, that is the difference between open platform and closed platform. So Microsoft is a closed platform, okay, and Apple is a closed platform. Okay, Cisco is a closed platform. Okay, whereas Linux is a open source platform. Okay, and then proprietary. So these cases, we have lot of devices. If you look into the traditional network appliances, okay, or like a message router, CDN server, and then VO voice over IP session border controller. Okay, so look into these devices, or everything you need a device hardware basis. Okay, all are hardware basis. 7, 8, 9, 10, 11, 12. So these are the hardware basis. And just you see these devices, or just convert them into software basis. Okay, network appliance deployment. Okay, network appliance deployment. And you see that this is orchestration. Okay, orchestration means you putting them together into a single place. Okay, single place, and it can be shared, and it can be high super performance. Okay, and it's like we can say it's more than super, you can say hyper performance can be achieved through this network function virtualization. That's what I can say here. Okay, automation and remote installation, everything is possible with network function virtualization, right? So all network elements are enclosed boxes, and hardware cannot be shared. This is about the traditional network. Each device requires additional hardware for increased capacity. Okay, but this hardware is idle when system is running below capacity. Okay, so it means that you need a lot of support with one another to support to run the network functions. Whereas network function virtualization technology, or SDN technology, that gives you a lot of opportunity to implement the network functions, and whenever it is required. Okay, that's what I can say. And what are you see these benefits? Standard high volume. Okay, that standard high volume storage, standard high volume Ethernet switches. These are the conventional things that is entirely automated, and that gives more than these benefits, and it can achieve high throughput, right? So with NFV, however, the network elements are independent. Whatever I said before, that is being repeated here, and then applications that are flexibly deployed on unified platform comprising standard servers, storage devices, and switches. Okay, so this is the independent application, and in this way, software and hardware are decoupled. Okay, and capacity for each application is increased or decreased by adding or reducing virtual resources. So this is the important point we want to understand here. Virtualization, see, depends on, for example, we use VirtualBox and VMware, and this is again, we can run the maximum capacity based on the virtual environment like VirtualBox or VMware. So if your base computer has more memory, more storage, and that can be super performing virtual environment or virtual box or virtual VMware or hypervisor. It can be used as a high performing software based network environment, and that gives you a high level output and performance, and the network traffic will be managed very easily, okay, with the high end virtual environment. And in that high end virtual environment, if you are adding all these devices virtually, it means the software based, and then it will be really it's comfortable, as well as we can expect the high performance in the network environment, right? So what are the features here? Okay, so it has been noted that a lot of features available, so it is totally from hardware to software. Okay, move functionality to software. So use commodities hardware platform instead of proprietary platform. So it means that you can use any hardware platform for doing the virtualization. Okay, and use standardized or open application program interface, right? Any program can be used for developing the virtual software, the devices. Okay, it means that the application that act as a router or switches, and also support more efficient evolution, okay, and deployment and repositioning of network functions. So it means that you can just to have efficient way to communicate with other network devices. So this is one of them. And the other concept we are going to, this is the features of a network function virtualization, and the mainly we can say hardware to software, and we can say the commodity hardware platform instead of proprietary hardware. Any hardware we can use, okay, any hardware we can use, okay, and then any standardized, okay, or open application can be used, okay, open API can be used, okay, and then it has more efficiency in terms of evolution, deployment, repositioning, and network functions. Okay, so concept. So what are the various concepts we are? So students, you need to understand these things when you go through the short answer and multiple choice questions. Okay, so NDF concepts are like network function virtualization. So what is network function? The first point we want to understand is a functional block within infrastructure that has well defined external interfaces, okay, and well defined functional behavior. Okay, example of network functions are firewall, load balancer, wireless network access point. So this kind of the functions must be emulated into software form. Okay, so that can be possible with NBF, right? Then physical network function, okay, PNF is an implementation of a NF via tightly coupled software and hardware system. This is typically a proprietary system. It means that you need to have kind of software and hardware working together, but this is a proprietary system. Okay, so network functions, it is normally okay, for example, Cisco routers. Okay, Cisco routers are used in the network for forwarding traffic and finding shortest path. There's so many other things it will execute. Actually, it executes a lot of other operations, and that is physical network function. So with the device and okay, tightly coupled. Okay, tightly coupled means what do you mean by tightly coupled? It is something you will do the configuration using hardware and software. Okay, virtualized network functions is an implementation, VNF again. So we are coming to NF, okay, and PNF, and then now VNF. So it's an implementation of NF that can be deployed in the NFV. So NFV is kind of a network function virtualization. I is infrastructure. Okay, I is a infrastructure. So this put together, okay, NF that can be deployed in the virtual environment or infrastructure or environment, or we can say the infrastructure means kind of things all together in one place. So NVF is again is a principle of separating network functions from the hardware, and they run on by using virtual hardware abstraction. So it means that the abstraction means what it is. You don't know what is the function of the device, but it functions. For example, the router. Okay, the router functions are very clear. Okay, but you may not be understanding or need of understanding the functions of routers. Okay, it runs as a normal fashion, and it does the job of the router. Okay, so this is the case of network function virtualization, the principle of separating network functions from the hardware. Okay, so function from the hardware, so it means that we need to put them in anywhere that works. Okay, put them in anywhere that works. So 2 points to understand here. The concept is here very clear, that separating okay, network function from hardware, right? NFVI, network function virtualization infrastructure, totally of all hardware and software components that built up environment which virtual, okay, network functions are deployed. Okay, this is the idea. So it's infrastructure is it's been we need a hardware. We cannot say we are going to eliminate 100% hardware. No, we are going to minimize those hardware that runs on router and switches and access point, firewall, IDS, IPS, everything. Okay, but we at the end we will be using the infrastructure that has high end hardware that holds the virtual environment. Okay, so it can span across several locations, the network providing connectivity between location considered to be part of the NFVI. Okay. Next, see the framework. So what are so many concepts we see here? Okay, NF, PNF, BNF, NFB, NFBI. Okay, so these are the various concepts you must be understanding. And then now we move on to the framework. So what are the framework? Mainly consists of three domains. Okay, three domains of operation. Three domains of operation. The first one is, okay, virtualized network functions, network function virtual infrastructure, and network function, okay, virtualization, management, and orchestration. Okay, orchestration. So if you look into the three domain, so the first thing is virtualized network function, the collection of network functions implemented in software that run over NFVI. Okay, so collection of network functions. So what is a collection of network function here? We can say, what are the collection of network function here? Routers, okay, routers, switches. Okay, so like function means we can say routing, switching, okay, firewalling, okay, these are the functions, collection of functions. So that is implemented in software. That's a main thing you need to understand. The functions are just, okay. And then the infrastructure is something performs a virtualization function on three main categories of devices in the network service environment, which are computer devices, storage devices, and network devices. Yes. Okay. And also the management and orchestration, it is something we will put them together, monitoring them, and making them working together. Okay, that's the main idea, right? So network function virtualization management and orchestration focuses on all virtualization specific management tasks necessary in the NFB framework. So that's the main idea we need to understand in this point of view. Okay, right. So what is a management? So checking the functions of network in a right direction. Okay, so all those devices, monitoring, alert, okay, finding out the statistics, analysis of functionalities, everything comes under the management. And orchestration focuses on virtualization specific management tasks. What are the management virtualization specific management tasks? So it is when it comes to virtualization, all of them become a um, uh, software based tools that can be used for network function virtualization. Okay, put them together and it will be in the necessary in the NBF framework. So if you look into the framework, we have VNF, okay, and then NFVI and NFV management and orchestration. Okay, so three domain of operations we are going to see the framework of uh, NFB, okay, network function virtualization. So what are they? Virtualized network function infrastructure, network function virtualization management and orchestration. So you have to understand that virtualized network functions are those functions from hardware to decoupled from hardware to software. Okay, and the other one, it is like performs a virtualization function on the three main categories, like computer device, storage devices, and network devices. Okay, so then we see monitoring, management, and orchestration making every device function together. So considering the framework, so if it is very clear that network function virtualization industry standard group, okay, industry standard group, So that's another part we need to understand here. Okay, industry standard group. So if you look into that VNF, virtual network functions, okay, virtual network function, right? These all are the virtual network functions. So it means that routing, switching, everything. And then infrastructure, we have virtual computing, storage, and virtual network. So everything is virtual. And then computing hardware, storage hardware, and network hardware. So these all are come into the framework, and then finally we see the monitoring. So VNF, the previous slide, here we are summarizing here again. NFVI, and then NFV, okay, management and orchestration, and then this is the idea. Okay, so this framework supports the implementation of network function as the software only network functions. So this is the main idea. We are coming back to back again and again, the software only virtual network functions. So we use this to provide an overview of the network function virtualization architecture, right? So if we come to the infrastructure, that is network function virtualization infrastructure. Again, we are coming back to the main area. There are three domains like hypervisor domain, compute domain, and infrastructure network domain. And if you look into the hypervisor domain, we have virtual computing, virtual storage, and virtualization layer. Okay, it is the virtualization in layers in between the hypervisor domain and the computer domain, and also that is the part of virtual network and the network hardware, infrastructure network domain. Okay, so in this slide we see here NFVI encompasses three domains. What are they? Hypervisor, okay, hyper, and we can say infrastructure, okay, infrastructure, and then compute domain. So the compute domain is, okay, compute domain is what you call it provides commercial off the shelf, okay, commercial off the shelf COTS, okay, high volume server and storage, okay, computer domain, it's a hardware. And then the hypervisor domain is mediates, okay, hypervisor domain is what? It mediates the resource of the compute domain to the VMs of the software appliances, providing an abstraction of the hardware, okay, providing the abstraction of the hardware. So what is mean by abstraction here? So nobody knows how these functions, okay, the abstraction, okay. So it done the job of all kind of virtual tools, virtualization tools, and that comes under the network functions that we write as a software, and then we implement inside the virtual machine. Okay, so this is a hypervisor. Hypervisor, again, normally we can say like virtual box, okay, VMware, and then Microsoft Hyper, okay, hypervisor. So these are the various kind of things, like we have all this virtual computing and virtual storage. So you can say here you have a computer, it takes the RAM and CPU, and also the hard disk. This is the hard disk, okay. So this is the hard disk it uses. So virtual storage, virtual computing, that is a hypervisor, right? Infrastructure network domain, it comprises, okay, this is the infrastructure network domain, all generic high volume switches interconnected into the network that can be configured and supply infrastructure network services. Yes, right. It's very clear. Generic high volume switches interconnected into network. Okay, that is the infrastructure. High volume switches interconnected into a network that can be configured to supply infrastructure network services. So it means again the hardware that supports the virtual network. So it means that the switches are here we have used for the virtualization purpose, and they runs in a abstract manner, right? So what are the benefits of NVF? So if NVF is implemented efficiently and effectively, it can provide a number of benefits compared to traditional network approaches. Okay, so this is again we can say it is reduced capex, okay, and then opex. Okay, capex opex is something capital expenses and operational expenses. Okay, capital expenditure, operational expenditure, that we'll see in the coming slide. Okay, so we have a lot of other benefits like reduced capex, reduced opex, and ability to innovate and roll out services quickly, ease of interoperability, use of a single platform for a different application and users, tenants, and provided agility and flexibility and wide variety of ecosystems and encourage openness. So if you look at this capex, okay, few benefits you have to just remember, like capex, opex, okay, and rollout service quickly, and interoperability, and then applications, users, and tenants. Okay, applications, users, and tenants, right? Tenants means anybody who come and borrow your switches, routers, and other things that can be those users can be called as tenants, right? Like, and provide agility and flexibility. So it means that expandability, scalability, so everything is possible with and the load, a heavy load can be shared with these things of these kind of NBF NFB implementation. And also openness. Openness means anyone can do create those software based switches, and okay, and then they can implement easily. So let us see one by one. So here I have given some highlights. The capex is a company major long-term expenses, while operating expenses are a company day-to-day expenses. That is really reduced very clearly. So how this can be benefited with capex? So the commodity servers and switches, right, consolidating equipment and supporting pay as you grow models to eliminate wasteful over provisioning. So over provisioning means what? You have to buy as you grow your company, or the scalability. Whenever you apply the scalability, like you improve your company, or you are going to open another branch office, then you must have to install, or you have to invest amount of money that can be considered as a capital, like company major long-term expenses. So you need to have kind of equipment cost, okay, that has to be implemented in order to extend your company. But in this case it will be reduced because NVF, it is all software based, and that can be used anywhere. And also operational cost, okay, in terms of power consumption and space usage and reduced network management control expenses, these reduce the daily operations operational expenses, okay, and that is very interesting. Okay, and also reduced capex and opex are perhaps the main drivers for NVF. So this is the important point, so why we use it. And also there are other functionality, so we can just incorporate into the NVF. And then we come to the point of ability to innovate and roll out service quickly. It means that reducing the time to deploy a new network services. It means that you need a switch, immediately you can do that. Okay, you need a router, you can do that immediately. Okay, seize new market opportunities, improve return investment, new services. It's very easy. For example, you want to implement a ATM machine, it's very quickly you can implement, because you don't need to run on any kind of hardware based switches or router along with your ATM machine. But whereas you can have the NFV that can easily provide the service. And interoperability is that is the main goal of our network standardization, and that is it can operate on any device. Okay, interoperability, any device. Okay, any device or any system. Okay, like OS. Okay, any operating system. Okay, and run anywhere. Run anywhere. And this is like agility and flexibility, like scaling up down service to address changing demands. Everything can be it's the main idea is scaling up. You can grow your office in any number of times. And then you can see a single platform for different applications, users and tenants. So that is the platform here. It is a network function virtualization is a single platform. Okay, so that's very clear that here we have a single platform which is uh, NF. Okay, for different application user tenants, allows network operator to share resources across services and across different customer bases. So this is very clear as well. A wide variety of ecosystems and encourages openness. Okay, so it means that anybody can innovate. Okay, and also it opens the virtual appliance market, pure software entrant. And small players, it means small environment, I mean entrepreneurs. Okay, and also academia, encouraging more innovation to bring new services. It means that anyone can innovate. Okay, innovate. So NF, now we go into see the contrast. NFB and SDN are independent but complementary stream. Okay, independent. So this is entirely different, but it can complement each other. Okay, so the SDN decouples, again you have to think of couple and decouple. Couple means together, decouple means separate. Data and control planes of network traffic. Okay, network traffic control, making the control and routing of the network traffic more flexible and efficient. Network function virtualization decouples network functions from specific hardware platform via virtualization to make the provision of these functions more efficient and flexible. Right. Then virtualization can be applied to the data plane function of the routers and other network functions, including SDN control function. So either can be used alone, but the two can be combined to recap greater benefits. Okay, so if you put NFB plus SDN, okay, together, you will get a greater benefit. Okay, if NFB is used, the network functions are implemented in software and executed on VMs. So this is the normal obvious reason we use NFB is used. Network functions are implemented in software and execution on VMs. So this is very genuine reason, like implemented in software. If instead of network functions are implemented on dedicated machines and SDN is used, the control functions are implemented on central SDN controllers which interact with the network devices. Right. If both SDN and NFV are implemented for a network of the following relationship hold, data plane functionality is implemented on VMs. The control plane functionality may be implemented on dedicated SDN platform or an SDM VM. Okay, SDN VM. So in either case, SDN controller interacts with data plane function running on VMs. So we are seeing now with the NFV and SDN, if they are together put into one framework, and then you will get a greater performance achievement. Okay, so that's what we are seeing now. Okay, all these things come together, and initially we see what is SDN and what is NFV. Okay, this is okay question mark you can put here, and then we discuss about more detail about the virtualization can be applied to the data plane functions of the routers and the other network function including SDN control functions. So we study a lot of things about this, you no need to explain here again and again. And if they put together, if you put them together, you reap greater benefits. Reap means you will get a lot of benefit. Okay, so instead of network functions are implemented in dedicated machines, okay, and SDN is used, the control functions and implemented central SDN controllers which interact the network devices. So this is also another benefit of SDN. Okay, data plane functionality is implemented on VMs. Yes, exactly. And the control plane functionality may be implemented on a dedicated SDN platform or on an SDM VM. Right. Okay, quality of service in NVF. Okay, that is another issue we want to discuss about it. Okay, and this is mainly it's not an issue, it's kind of we get the better performance because of the software based devices and their agility and their flexibility that makes lot of functions into reality, and that gives you a very clear picture how these network traffic smoothly running, and that gives you a lot of benefits. So quality of service measures commonly use specific the service required by various network customers, users, and to dedicate the traffic management policies based on the network. The common case until recently is the quality of service was implemented on the network that used neither NFV and nor SDM. Okay, so it's not much implemented, but in the future it will be there because the quality of service is required. We want to achieve the customer experience and customer what is that, the involvement and the requirement to be met with the clear NFV and SDN. Okay, so the common case until recently is that QoS was implemented on a network that use neither NFV. So no, in a simple word you can say no QoS. Okay, no quality of services. Okay, in NFV, okay, and SDN. Okay, so in this case, routing and traffic control policies must be configured directly on the network device using a variety of automated and manual techniques. So also, if NFV but not SDN is implemented, the quality of service settings are communicated to VM. So it is the VM we consider more on quality services. quality of services. With SDN, regardless of whether NFV is used, it is the SDN controller that is responsible for enforcing quality of service parameters for the various network users. Okay, so the VMs, virtual machines, uses quality of services. Right. Thank you very much, students. If you have, here we come to the end of the chapter 9, and if you have any doubts, you can ask your teacher. Okay, and you can go through this video, and uh, there are a lot of short answer and in fact long answers, multiple choice questions may come from this chapter very well, because it has a lot of concepts and definitions, right? Thank you very much, students. Thank you.